Okay. So we got minimum and maximum application or optimization. Okay, so we did do some of this last year for those of you guys that were in calculus last year. But basically what we're going to do is we're going to take a shape, okay, and we're going to be given one piece of information, and then we have to optimize another part of it. Okay, so the procedures for this that they give to us are, first we're going to make sure that we have correct variables. Okay, you can draw a picture if that helps. Okay, I always think that does help. Okay, then you're going to write the primary equation, and then we're going to isolate whatever has to be max or min. So how do you find a max or a min, by the way? Derivative. Okay, so we're going to derive it. Okay, then we're going to write it so it only has one variable. Okay, that's going to be a key piece. You only want to derive in terms of one variable. This could require the second equation, so if we're talking about like a perimeter and maybe we're maxing out an area, that's where two equations are going to come into play. You want to make sure you understand what the domain is, because if you're working with area, you can't have a negative amount of area. And then we're going to find critical numbers, do our number lines, and find maxes and mins.
Wow.
Piece of cake, right? All right.
Sounds like a...
All right, so example number 1. Okay, this is a great example with the holidays coming around because all of the people are putting stuff in boxes, right?
Right.
Perfect. Well, you never know. You just might be.
You know what? Maybe I might. You're right.
You just might. All right, so we have a box, and this particular box does not have a lid. Okay, so that's important information. And it has 48 centimeter squares of material. So what is that piece of information that they're giving to us right off the bat? Okay, that's a area. Okay, so area, we're talking about like a surface area. Okay, and we know that based upon the centimeter square. Okay, if the box must have a square base, find the dimensions so that the box has a maximized volume. Okay, so the first thing that we're going to do is we're going to talk about the given information, okay, which is our surface area, and then we're going to max out the area, which is going to be a different equation. Okay, so let's start by looking at our box and just labeling sides of the box. Okay, so one of the pieces says that the base has to be a square. Okay, so give me a length that we should identify and call the base. What? No, like a letter, variable. B for base. I like B for base. Okay, and then the height. Can we go ahead and call that? Well, let's just go with H. Sound good? Okay. So if we're going to talk about the surface area. Okay, how would we find the surface area of this particular box? Okay, so we'd add all the sides. So would you agree with me that the sides are all the same? And there's 4 of the sides that are the same. Okay, what's the area of each of those sides? The base times the height, right? Okay, so we have 4 base times heights, and then we have the surface of the base. So what is the surface of the base?
B squared.
B squared. Okay, so we know that the surface area is equal to 48 centimeters, the given amount. Sorry, I didn't really set that up. Okay, so that's the given information. Now we want to talk about the piece that we want to maximize. Okay, so we want to maximize the volume. You guys with me? Volume. See how we're going to maximize the volume. Okay, so now I want to figure out the equation that I'm going to need in order to maximize this. Okay, so how do you find the volume of our box? Okay, base times length times height, right? Okay, so ours is going to be h times b squared. Okay, so at this point I have a volume equation that's in terms of both height and base. Okay, we do not want to derive an equation that has more than one variable. Okay, so what we have to do is we're going to pick one of the variables and isolate it in our surface area equation, and then replace it into the volume equation, simplify it, and then derive it. Okay, so if I look at my surface area formula, the one in red there, which variable is going to be the easiest one to isolate? There's definitely a clear answer for this.
H.
Okay, definitely the h. Okay, if I have the b, we have a b squared, that's going to be like quadratic formula stuff. We don't want to go there. Okay, so if I isolate my h, how do you isolate the h? So first we would subtract the b squared, right? Okay, then what? Divide by the 4b. Okay, so we know that h is equal to 48 minus b squared over 4b. Okay, so now what I'm going to do is I'm going to take that piece and I'm going to plug it into the volume equation so that I have an equation of volume that is only in terms of b's. Okay, so when I do that, my h is going to be replaced with 48 minus b squared over 4b times b squared. Everybody good with that part? Okay, so now I'm almost ready to derive, but I don't want to derive until this looks a little bit nicer. So let's go ahead and simplify this. How would I simplify that? Okay, we could distribute. Do you want to distribute the 4 or the b squared first? Or should we simplify the fraction first? Does that make you feel better? Okay, so if we simplify the fraction, I'll do this really slow since it's a Monday. So we have 48 over 4b, and then I can simplify it into b squared over 4b. You guys remember doing this? Just breaking the fraction apart? So I'm just going slow right now, it's just so you can follow me. Okay. Anybody know what 48 divided by 4 is? 12. Okay, so we're going to have 12b. And then what if I have b squared over a b on the second term? That's a b over 4. Okay, and now I'm going to distribute the b squared through. Okay, so if I do that, that's going to be 12b squared over b minus what happens if I have b times b squared? B cubed over 4. Okay, and then we can simplify that a little bit further. My first term is 12b squared over b. That's the same as 12b, and then I have, we can rewrite this as 1/4 b to the third, so that's just a really easy basic. Okay, so now, really the hard part so far has been the algebra. I have done no calculus at all, right? Okay, so now I'm going to derive it so I can find a max or a min. Okay, so for me to derive this, what is the derivative of 12b? 12. 12. Okay, what is the derivative of negative 1/4 b cubed? Good. Okay, and now how do I find my critical values for maxes and mins? Good. So now I set it equal to 0. All right, so if I set this equal to 0, what would you do first? Move the 12. Can I go ahead and make it positive since it's going to be a negative on both sides? Okay, then what? Oh, sorry, it's glitching out.
Wait.
So multiply by 4/3 to get rid of the 4/3. So 12 divided by 3 is 4. 4 times 4 is 16. So now my last step, square root. So what's my b value? 4. Okay, now technically if I'm solving an equation and I take a square root, I should have plus or minus, right? How come I didn't write the minus? Okay, good. We can't have a negative length or a negative base. Okay, so I should do a number line test just to make sure. Yes.
Wasn't it negative twice and also positive?
Well, we had it would be negative 12 equals a negative 3/4.
Oh.
So I just made them both positive. Okay. So to do a number line test, we want to make sure that this is in fact a max. Okay, so remember I'm testing this against my first derivative. Okay, so it's way back up there. Oops, that's not the right spot. My bad. First derivative, I had that on the original equation. Okay, so if I pick a value that's less than 4, such as 0, would I get a positive or a negative?
Positive.
Positive, good. Thank you. And if I plug a value that is bigger than 4, such as?
Definitely negative.
Okay, you do get a negative. So this goes up and goes down, so what do we know about this point?
It's a max.
It is a max. So we do have a max when the base value is 4. So now how do I find my h value? Yeah, plug it back into that red one way up there. So my h is going to be 48 minus 4 squared over 4 times 4. So 48 minus 16. What do you know what 48 minus 16 is? And 32 divided by 16 is 2.
Perfect.
Doesn't it come out nice? Okay, so the dimensions of the box are going to be base, 4 by 4 by 2. And we should label this in terms of what, centimeters? So did you follow all that?
Yeah.
So the calculus part is super easy, right? I mean, it's really not much different than what we've been doing, finding maxes and mins. It's just the part with the algebra where you have to isolate it for one variable. Okay, let's try one more, and then it'll be your turn to work. All right, so this is always a question you see on like an ACT test.
Screw the ACT. I agree.
Well, let's see. You guys have, who's taken it? Jaden, you took it recently. Did you see a question like this on it? Oh, you didn't? Oh, okay. Then maybe I'm wrong.
I've seen it.
Have you?
I mean, I have, but I don't know the most recent one.
Oh, they might fluctuate too. Huh? Oh, these are not bad. Okay, so we have the product of two positive numbers being 288. We're going to find the two numbers so that the sum of twice the first plus the second is a small value, the smallest possible. Okay, so I'm going to start by writing the given. Okay, so the first equation comes from the first sentence. Okay, so I have two numbers. Product means what's happening between them. We're multiplying. So we're multiplying two numbers and their product is 288. Is everybody okay with me using just x and y to represent the two numbers? Sure. So we're going to say x times y is equal to 288. Okay. So the second piece, this is the one I have to optimize. Okay, so it says find two numbers so that the sum of twice the first plus the second is the smallest. Everybody get that equation? Okay, so we're going to find two numbers so that the sum. So what is the sum meaning? We're adding. So I'm just going to use S to represent sum. Okay, so the sum of twice the first. So how would you represent twice the first? Okay, 2x. And then twice the first plus, obviously plus. Sorry, I underlined it both. And the second, which would be plus the second being y. Okay, so spells out our equation. Okay, so the first thing that I have to do before I do my optimization is I have to rewrite my sum equation in terms of one variable. Okay, it does not matter which one we choose. This one is going to be 50-50 here. Do you want to isolate the x or do you want to isolate the y?
The Y.
Okay, sure. Okay, so I heard y. So if I isolate the y, I'm going to use my product equation to isolate it. Good. So 288 divided by the x. Okay, so then I'm going to plug that into my sum equation. So 2x plus 288 over x. Good. Okay, and now if you want to rewrite this, remember that when you have an x in the bottom, that is the same as 288x to the negative first. I'm sure some of you guys just do that in your heads by now, but just write it out anyways. All right, so if we derive this, what is the derivative of 2x? 2. And what is the derivative of 288x to the negative first? Good. All right, so now to optimize, I'm going to find my critical values. And how do I find critical values? Set it equals to 0. And I'm going to throw that x squared downstairs. Okay, so to solve for that, what would you do first? Subtract the 2. Same situation here. We're going to get a negative negative. So everybody okay with me just keeping it positive? 288 over x squared. Okay, then what?
X squared.
You with me? So multiply by x squared, and then what?
Divide by 2.
Divide by 2. Anybody know what 288 divided by 2 is? Isn't that nice? The nice thing is that they usually give you nice numbers on these.
Well, until we get.
No, I think even on the homework they do. They do even on the homework. All right, so even though I only found one critical value, I do need to make sure. Oh yeah, no, good question, my bad. Come way back up at the positive, this part right here. So we'll just use the positive. Okay, so now remember that we're testing this on our first derivative. Actually, let's go to this one. Okay, so if I plug a value less than 12, such as 0, into my first derivative, do I get a positive or a negative number? Yeah. Negative. Well, you can't use 0, actually. So for starters, you can't use 0, my bad. So you have to use like 1. 1 would be the easiest, because 0 is an undefined value. You can't have x in the bottom. Because then it would just be 2 minus 288, right? So that would be negative. So if I plug like 13 in, now I'm getting a positive. So this is going to go down and up. So now I can see that this is, in fact, a min value. Okay, so how do I find out what my y value is? So anybody know what 288 divided by 12 is? 24. Good. Okay, so your two numbers are 12
24. Oh, you got it.
and 24.
I tried, all right.
All right, so you guys have